Color is one of the most obvious features of soil, but it's also one of the most misunderstood and misinterpreted characteristics. So let's look at soil color, how we describe it, and what it can tell us. We need some standard to be able to describe colors. The blue of blue jeans is different between when they're new and old and worn, which is different from the blue in the background of the white stars and the U.S. flag, but they're all blue. Similarly, most people would say that soil is brown, or maybe soil is red, but when you look at all those different colors, they're not all the same shade of brown or red. So if a soil scientist wants to communicate a color, he needs a standard, she needs a standard in order to communicate that to anybody else on the planet that has access to this same system. So the system that we use is the Munsell soil color notation. It has three components: hue and value and chroma. And you see pages like this within the booklet. So what's hue? Hue is the mixture of primary and secondary colors based on a ratio of 8. So 8 parts to 0, 7 to 1, 6 to 2, etc., until you get to 0 to 8. The most common color combinations in soil are these that create browns, which work with the combinations of yellow and red. A little more rare as you go toward the right here, green and yellow combinations, and blue and green, and purple and blue. And those are the things that happen in soils as oxygen becomes limiting. Each page in the color book is a hue, and the hues are identified by a number and a letter or letter combinations. So here we have the hue, and on the left we have 8 parts red, no yellow, and that one is identified as 5R. Now you'll notice as we go across this book, the colors change. When you look toward the top right, you'll see that in general we're moving to kind of reds to oranges to yellows. And what's happening is you're moving across there, you get to the part that has 0 red and 8 parts yellow, and that one is identified as a 5Y. The next characteristic is the value, and the value are these numbers you see here. It's the ratio of white to black. 10 is pure white, 5 is gray, and then 0 is pure black. So in this case we have the color book, and on that side the value runs vertically, going from 8 to 2.5. The chroma, I call it the intensity or the brightness. You see across the bottom, the 1 is a dull color, and when you move to the right on the book, the colors get brighter. So the chroma is defined as the ratio of hue to value. I don't really understand that, I just accept it. But 0 then is all value. So there's no chroma, it's all black or white. And 20 then is all hue. So there would be no black or white mixed in. To think about this as the color intensity. Colors are more intense. I sometimes liken it to mixing paint. If you start with a neutral base and you start adding pigment, the more pigment you add, the brighter and more intense the color is. So that's one way that I think about the chroma. Now let's use the color book here. We see there's an aggregate behind the color page. This one fits with the 10YR best. I selected that of all the hue pages. And the aggregate is between these two color chips I did all the matching and moving it around till I found those where I think it fits best. And even at that, it fits the chip below a little better than the chip above. So when you read that across, the value is 4. You read down and the chroma is 4. So the color is identified as 10YR44, and that's a complete color notation. And for those of you who would like a word description, that is a dark yellowish brown. So what does soil color tell us and what doesn't it tell us? Well, color has nothing to do with soil texture. So black soils are not loams. There are black sands that are volcanic that you can find in Hawaii and many other places. So black isn't loam. And this one is red. Many people would be tempted to say that that's a clay, but that's not right. This soil is a sandy loam and at most a sandy clay loam. So no, red isn't clay. And just because something is sort of tan doesn't mean it's a sand. So color and texture are not connected at all. One thing that color does generally tell us is organic matter. Not always, but generally, darker soils contain more organic matter than lighter soils. Now, this is especially true within a profile, within one soil type. So what you see here are 4 aggregates taken from the surface of soils that have been managed differently. The one on the right has been in conventional inversion tillage methods that leave it basically bare most of the year except when you've got corn or soybeans growing on it. It's very degraded. It's light colored, a 10YR32. The soil surface structure is in bad shape. Now, 5 years before this picture was taken, they saved that soil from its conventional tillage and planted it to grass. And you can see that there's a little bit of structure forming and that the color's darker. The one next over has been in no-till for 12 years. The color's darker, and you can see that there is evidence of more structure as we're increasing the organic matter. And then the one on the left is from a native tall grass prairie. So it has never been plowed. Really dark, almost black. And you can see aggregates that are beautiful granular structure. So if you look at the color gradient, it went from a 10YR32, 10YR31, 10YR21, and 10YR11. So we didn't change the hue, and mostly we changed the value, although the chroma changed once as well. Another thing that the color will tell us is about mineralogy. So these bright orange and red and yellow colors are about oxidized iron, not about clay. And these pinkish colors at the bottom are calcium carbonates. They can tell us about chemistry. These bright red colors are that oxidized anhydrous iron. Anhydrous means it doesn't have a shell of water around the iron molecule. If you put a shell of water around the iron molecule, you get hydrated iron and the colors come out yellow. And then you can get these reduced colors that are grays. Now, the color is a dye around a soil particle. So if you remove all the dye, you get these white powders that you see here. You can see some color in the particles in the background, but the ones on the surface, all of their color has been removed. Now, we're going to look at some cool colors in aggregates that I found and have worked with, have broken open, and have a lot of fun thinking about these because some of them are almost art. So you get these oxidized, hydrated yellows, that dark, rich, organic black. We can get these reduced grays, and then when you get hydrated and anhydrous oxidized irons, you get the yellows and reds that come together to make the oranges. So as we look at this one, you can see the color combinations and even some roots in there that are different colors. Almost becomes art because the coatings are in the pores and in the root channels, and they're on the particle surfaces. So what you can see here, that's a root channel, and the oranges show up because oxygen goes into those channels and the soil kind of rusts. As you can see here as a close-up, you started with that grayish soil that is reduced, and just like if you leave a shovel or something out and it gets wet and goes through wetting and drying cycles, the shovel rusts. Well, the soil essentially does the same thing. But you can even see that there are some coatings on the root surfaces, both the organic materials and the iron. So color is one of these things that we use to identify the layers in the soil. We also use the structure, that's the shape of the aggregates, those chunks that you see, and the texture. Now we can see color and we can see structure, but texture, you can't see it. You have to pick it up and touch it and feel it to really understand the texture. So we've got these lines across here and some letters. Those letters are soil science nomenclature then to describe these horizons or label those. But you can see a difference in the color between the AP and the BK, and then between the BK and the BKK1, there's a difference in color. There's a little difference in color even, but more of a difference in the shape of the aggregates. And if you had a bottle of acid and you dribbled it on it, you could see that there's also going to be a change, the greater amount of fizz as the carbonate compound content is increasing. So if we look at another soil profile, you see that the color is somewhat lighter at the top. It gets a little bit darker under that, and then it turns kind of reddish as you go down, and then it gets pinkish at the bottom. So the color is the first thing that we're going to use to approximate those lines, and then we're going to go in and we're going to look, see if we can pull out some structural units, those aggregates or those clumps. And then from there, we'll dig around and then we'll start touching it to see if we can find differences in texture. We'll use the texture by feel in the field, maybe do some more extensive lab work when you get back into the lab. So that's your quick look about soil color, what it tells us, what it doesn't, and how we describe it.